Okay, so today I'm going to demonstrate some improvements to our engine. This is going to enable us to edit our worlds and save it to disk, so kind of like Unity's scene system. And in order to properly execute on this, we needed to come up with a basic entity system. And I did a bunch of research, poured through a couple of the game engine architecture books that I own, watched some videos on YouTube just to kind of see what other people are doing. And I'm taking a much simpler approach to Unity because I was very frustrated with how messy the behavior or the functions can get with components. So you have like 10 components, they have 10 update loops happening all at once, and you're trying to synchronize that behavior across all of that. And I want to avoid that. I think an entity at most should have one function for its update, and that's it. And that doesn't need to be tied to the entity data, whereas the components themselves are more data driven, and we can have a function, plug in all of the components that we need to operate on, and then it just works, right? And we make a function for a melee agent, for the razor nun, for specialized entities that do different things. And then we can also reuse those functions if it makes sense, or we can break them down into smaller functions that are reusable. Then we can compose AIs in a much more sane way. Things like saw blades, those can be decomposed into basic components like damage, collider, sprite. And those by themselves don't need much fancy logic, but there will be a damage function that we can call on all damage components. So I don't want anyone to think of this as a Unity equivalent, because it's not. And as you'll see real quickly here, we have our entity, which has our position, scale, and rotation. I'm considering moving this to its own struct as a transform and getting rid of the concept of an entity, because I think an entity could just be an ID. And then, of course, we can use that ID to basically find all the components that belong to that entity. But for now, I'm sticking these things all on the entity. And then we have a sprite, which is our first real component. You can ignore the character renderer down there. That's going to change, possibly. That might actually end up being another component. But these things are just structs. They have no functions internally. And most of the stuff in this project will not have functions inside structs, because you don't need to do that in C++. In C++ or C, you can just put functions in the global namespace, which allows you to decouple your behavior from your data, which is absolutely wonderful. I'm so relieved to be out of C# hell, where everything has to be a member variable. So this is how we've structured, or we're structuring our components and entities. And right now I just added a sprite. And internally, the engine is able to operate on an array of sprites and render those to the screen. And so, yeah, in somewhere else in the code, we have an array of sprites that are initialized at start, and then we load stuff into that from the level. So let's take a look at the level. So let me just delete a handful of these things. So what I was doing previously was, you can see there's a lot of teleporters here because I was able to export all of those out of Unity. This is basically our scene format, which I call world. And the reason I call it world is because it represents like Excoria, Sludgehaven, etc. And unlike Unity, where you basically have to create a scene for every state of your game, we won't be doing that for Cultist, because like the main menu, for example, is a mostly hard-coded thing, right? It has UI. Maybe we define the UI in a file, but we don't have to. but it doesn't have the same characteristics as a level, right? It doesn't have rooms. It doesn't have a starting position for the player. It could, and if we wanted to do that, we could turn it into a world, I guess. But the idea is like we use these specifically for levels, and if we need to, we can introduce other formats for other things, and we can specialize, which is better in the long term because then you're not dealing with a bunch of abstractions and, generalities that just make things more confusing. So in here, you'll see we have a player position where the player starts. Again, this will be improved once I start porting over checkpoints, but that's how we're doing it now. It also tells the game which room to start in, and then underneath this we have a room array. So that index 20 next to start room is basically the index that points to the first room. And I exported this out of Unity, and for whatever reason, when you do find objects of type on infinitive room, it gives you this freaking order, which doesn't make any sense because in our scene in Unity, it goes top to bottom in order that we specified. So Unity's doing some magic find thing. This probably explains why execution order is super random, because Unity doesn't start from the top and go to the bottom. It has its own way of, I guess, iterating these things. But the first level is at the bottom, and these don't make any logical sense. But anyway, 20 literally points to this. And then this is before I created the new entity system, but this is how I was representing teleporters in the file. So each one of these 4 blocks is a new teleporter. And this does work right now. I haven't changed this over yet, so if I was to like jump into the game, you'll see, oh, and we have an error, which is strange because I just fixed that. Oh, teleporter's gone. So I was going to show you this, but I deleted that PNG. So let me just comment. I can't comment things yet in this file. I'll just delete it for now. So yeah, when I run this, you'll see that all the teleporters are loaded in, which means that this game is technically beatable in the sense that I can actually traverse the whole map all the way to the last room here. So there's that, and that's how I basically represent each one. And this is obtuse, right? It's also not scalable in the sense that like a designer like myself can't go in and compose a teleporter that moves, for example, right? Like I can't make a movable teleporter because our game engine says that teleporters are exactly these things. And so what the component structure that I'm doing is similar to Unity in the sense that you can attach multiple properties to an entity, and then the engine can detect those specific things like, oh, this has a health, this has a sprite, this has a damage component. They're very basic building blocks. And then we write logic that can operate on that. So there is still some scripting. This isn't like a magic bullet, like, oh, you throw, this specific component on something and it just works. For some components it will, like Sprite. Sprite basically makes it so that the rendering engine will render it. But for other components, we may have to write additional functionality, right? You can't just make a razor none component, slap it on, and expect things to work, because it's just the data required to have a razor none. We'll need to write the function that goes with that. But anyway, we want to make this better. So the first thing I did today was introduce the sprites. So we have this new format for entities, and maybe I'll tab these out eventually, like this, so it's a little bit easier to read. But for now, I'm just keeping it flat. So you have entity start, entity end, and then we have a position, scale, and rotation, exactly what you saw in the entity structure over here. So you'll see we have the same values. So this will be at 0, 0. You'll have a scale of 1, 1, and we'll have no rotation. And then the component start, we tell it, hey, it's a sprite, it uses this texture, which doesn't exist. That's why we had that error earlier. And then it uses this tint color, which is currently set to white. And then these are just ending these starting values. So it's kind of like JSON with the brackets. It tells you where it starts and ends. Okay, so then sprites. So basically I can take this basic door and I can change it out here. And then when I hit run on my project, this door will spawn in down here. I haven't set up any like pixel per unit stuff for the sprites quite yet. It's gonna be really easy to add, but just wanted to get the entity system up and running and get the serialization working. And then of course, I also added the ability to render sprites, which you think we would have already had, but tile maps are handled much differently. They're actually a grid that's being batched. And then the character itself is not even a sprite. It is technically using textures and all of that, but it's a animated mesh. So we don't treat it the same as these sprites. So this is just added today, right? I built a new sprite rendering system just for this. And there's still some kinks to work out with it, but as you can see, it is putting stuff on the screen. Now, what's really cool about this is the designer can come in and edit this. We're obviously going to put this into like an IM-GUI editor, which is probably what I'll be getting done tomorrow. But yeah, we can swap it out to this mimic door, which we have right here. And then, of course, if we want to, we can make it larger, and we can set the position to 5, and if we wanted to, we could rotate it, but I'm not going to. And now you will see we have that door spawning here. But not only that, the system, or the world file, can have multiple. So I can spawn in multiple objects. So this is 5. Let's make this 8. Let's make this 11. And we can make them different sizes. We can change the color. And we can load multiple textures. So let's get the artifact ceremonial razor in. Let's do the sculptures. And I'm going to make this art look really ugly because I'm tinting it. And of course, make sure the file is saved. So there's 3 entities that I've defined. Now when I run this, the editor will load these 3 things in, and it's really hard to see, but the book is there. We're making it super blue. Just to show this at full color, let's set the tint back. Tint is only really good for black and white things. I need to compare if it's the same. I believe it is the same because the other things I'm tinting, like the tile maps, appear to be the same as what's in Unity. But yeah, there's our textures, and some of these things are being scaled in a wonky way because I set them to like 1:2 here, as you can see. But yeah, this is really nice. This means that we're no longer hard-coded when it comes to loading sprites into our scene. And this is going to be very important for the teleporters. So now that we have this new structure, I can convert all of these teleporters over to entities, and I can create essentially a teleporter component for the room ID and the linked ID. And then of course, in the future, we're going to have teleporters that require button activation and don't require button activation. So that will just be another data parameter on a teleporter. And then we'll do the same thing for rectangles, which will be really just a collider component, or maybe I'll specialize that a little further and call it a trigger or a sensor. I think I like the word sensor, but it's essentially a trigger. And again, these aren't Unity style components. They don't have behavior. They're just data, which means they're really easy to serialize. They're really easy to edit, and then we just write the functions in in the engine that will process these. And that's why I don't like calling this an engine, because it's not just an engine, it's also the game. And, since we're a small team and we're not really interested in providing an all-purpose engine, we can do things like this where we mix the editor and the game together to really amplify development, because we're not going to be reusing this exact project for our next game. We might reuse portions of it, but if we're making a 3D game, we don't need tile map rendering, right? We don't even need the entity that I'm using here, because it's a vector 2 for position, it's a vector 2 for scale. It only has one value for rotation. And of course I could add the other degrees of freedom, but that's not necessary for our game. And if it becomes necessary, we can easily add it. So that's the progress for today. That's what I got done today. And there's other things behind the scenes that I also added, like I have a texture cache, which makes it easy for us to essentially load one texture for multiple things. So when I spawn in 2 or 3 doors that have the same texture, they're actually using the same texture reference. That's what this does. And then of course a lot of the work happened on the loading side. So there's like a whole parsing system that I built for extracting this information out of the world file. Now what's next? There's a lot we can do here, and this is going to be kind of similar to Unity's prefabs, but I think it's going to be much better because nested prefabs were a nightmare, and I have, I think, a pretty good solution for this. So I'll just give a brief overview of what this looks like. So basically we have this entity example.world. This doesn't work yet. This is kind of like what I want in the future. The format is also kind of wrong because I put colons and stuff in here, but anyway, this first thing here is exactly what I built in the other file, right? You can define an entity directly in the world. You can think of this as just like an instance or a direct instance. There's no reference, right? It's not being spawned in by from a prefab. It is literally hard-coded into the scene file or into the world file. And it's exactly what you saw there. It has the position scale. It is missing rotation because that's something I've added when I was implementing this. And then you can see it has that same sprite component. But it also has a sensor and it has a teleporter, and this defines a teleporter entity. Now, if we have 20 teleporters in the scene, I don't want to have to duplicate this data, right? Let's say let's say this is 20. And then I want to change how all the teleporters look. Well, in Unity, we would do that with a prefab, right? We would go to the teleporter prefab, we would change the graphic, and then it would update. But what I have to do is I have to copy over these two things, right? And so we don't want to do that. What we can do instead is we can use an entity reference. And this is a simple example with a position override. So you can see here, when we start the entity, we say, hey, it's actually a reference to this file. And you can see it's pointing to a sawblade ENT file, which stands for entity. And then we set the position to 5.5. So the sawblade entity may have a default position. Let's say it's 0, 0. It could be something else, but for simplicity, let's say it's 0, 0. Well, this position override tells it, hey, put it at 5.5. And so this is exactly what we could do that's similar to regular prefabs. So if I go to data entities, you'll see we have this sawblade int file, which I'm going to open with Notepad++. And you can see it looks exactly like an entity, right? It has the position, scale, possibly rotation. Here's a rotator component. Here's a damage component. Here's a sprite component. And here's a sensor component. And then we can feed that in to the world file when we go to load this. So when we're iterating over this and parsing it, we basically find this reference, and then we substitute, or we go to that location, open the file, read it in, and then we instantiate that object in this position. And then this just shows how you can override not just the entity, but also component values. So let's say I wanted to modify the saw blade even further. I can override the speed of the rotator and the damage it does, and maybe I can scale it up to a larger blade. And I can actually take this even further with the concept of, I'm going to say inheritance, but it's not code inheritance. It's kind of like the not nested prefabs, but like prefab variants, so to speak. So I can actually take this concept here, and I can stick it into a entity file. And now I have a variant of a entity file, and then I can load that variant in here, right? So it would look something like this, entity variant reference. It actually wouldn't be any different than what you see here, but we could say this is a big one, right? And then I can take this and I can copy it to here. So we want to do a new text document, saw blade big ENT, and then we have essentially the same concept, but it's using a reference. So it really is just like substituting. It's a type of compression if you think about it. So this this rolled file can become, you know, much smaller because we're not just dumping data into the scene. But sometimes that's useful, so we have the option. So that's next on the list. I haven't done this yet. I basically just got the top part working, but next is the reference system. But yeah, that's all I got for today.